Welcome to the second part of learning about ChopNetworks. Um, Now, in this lecture, what we're going to do is instead of just controlling the height, we're going to use these ChopNetworks to control the choice of the object that we're going to pick. So I've created an OTL for you guys. You'll find it under here under digital assets if you installed it, and it's right here, ornaments 3D. So this node, what it does for you, it creates you all kinds of objects in a certain order, showing more and more complexity. So going bigger, bigger, and so on. So I have about 8 of them, or let's say 9 of them, so different kinds of settings, different kinds of shapes. What else is in this node? You have also some information, so you can see that this is part 0 and part 1, 2, 3, 4, 5, and so on. So you have several options that you can just view the numbers that you have selected and so on. Now the idea what we're going to do is we are going to connect this right over here. In fact, I don't think I need the X-form right now, and I'm going to remove the stamp right away like this. So we just have like this whole ring of objects. Alright, so right here we have like this ShopNet function. We're gonna leave it where it is, and we go into our CHOP network and make sure that we are going to create waves that we can use to do a selection of objects. Now, a few things first. Something which is important to know. If you create harmonic waves which are combined together in some kind of a logical way, it creates always like good looking patterns. It is a little bit comparable to the rules of music. If people create music now, good music tends to be following those certain rules. For example, if you see this waveform over here, it's very chaotic. But if we have like this waveform going in ones and this one is going in thirds, we have like a pattern that we can follow. And just the same like we like to see patterns in geometry or in shapes and so on, we have the same feeling with our hearing. So that's quite similar. Now in this case, we're going to use it to select certain types of objects. Now something else. A second thing that is important to know is the waveforms. Right now, their waves are represented in time, measured in seconds. So if you go over here to your channel, you can see the units are put in seconds, and that's something we can change into frames, samples, or seconds. We're going to use frames later on. Something else which is important to see is the ability to have like also different kinds of waves. It's not that you only have like a sine wave, but you can have like a constant value which you can change in height. Yeah, period doesn't matter over here. It's the amplitude that you can see. We have the sine. A Gaussian is also sometimes useful, although I hardly use it. Triangles, these are very useful ones, and you can go on and on. So ramps, squares, pulse, also very useful, just having like little pulses on the right moment, and so on. Again, I will go to my sine wave. Now, the thing that I'm going to change here right away is I'm going to put it into frames. And as you can see, we don't have anything visible The reason is because the period is just 1. So it has to repeat itself on a 1 by 1 frame, so therefore we don't see anything. You will start to see once we have like 3 or even 4. This is better. And now we see our sine wave being represented. It's still a sine wave. It feels like it is triangles, but that's just because of the sampling. The start and end we're going to make a little bit bigger, since that we're working with frames. This is not seconds anymore, but just like a bunch of frames. Let's make it a size of 100. And the sampling rate, well, we just keep it as it is. So that's something we're not going to touch. Alright, so let's have the same thing over here. I'm gonna make this also, let's say 100. Make this one in frames and have those ones combined. So right away you start to see like some patterns starting to emerge. Let me go a little bit further until we have like a nice pattern which we feel we can use. Perhaps something like this. Let's see, is there something further on which is perhaps more interesting? No, let's just stick with this one as a start. So quite simple. We have all these hook-like patterns. Now the thing is, we have like one, two, three different heights. Now what I want to do is to make sure that immediately from the result we have over here, we have like the right settings. So selecting 1, selecting 0, 1, 2, and so on. That's like really using perfect frames instead of us having to use, for example, all kinds of expressions in order to force having a proper selection. Now if you want to see the samples over here, we can just press D, and this shows us exactly where those points are. So that's the result we're having. Okay, now the next step what we're going to do is, first of all, we're going to normalize, and again it's very important to normalize. We want to make sure that everything fits between 0 and 1. And we'll have to do it probably in 2 steps. One solution to that is using the limit function. So the limit function has like lots of possibilities. What you can do, we can say normalize, and as you can see, everything is now put right in between. And that's the major first step. And the second step that we're going to do is again create a mouth node, because what I want to get is to have them between, instead of like -1 and 1, I want to have it from 0 to 1. So it's the same node, so we have all kinds of combination things that we can do, but we have also over here some tools that we can do. For example, we can do a pre-adding. So we add 1, so everything goes up, and then multiply by 0.5 and goes down. Again, this is the really powerful usage of the Chop editor. If you're not like really used to work with mathematics, you can just start to play around and you see the result right away, and you see everything multiplying, and you can figure out that like that you can create a good result just by playing a little bit. It's best of course to play with each channel individually, but that should help you to figure out how things are working, especially if you see it on a global result such as this. Now another thing that we want to do is we want to make sure that we have like all these samples properly aligned, because right here we can see that they're not like really sitting on the right edge over here. Now therefore we're going to create again 2 nodes. again, it's going to be a limit node and a math node. And with the math node, we're going to do one thing. Let's go over here. So I'm first going to show you the math node to show the result. We're going to multiply it so that each one of these values is sticking nicely and fitting on what it should be. So if we go over here, well, we should get something more or less like this. So times 4. Now this is very useful, and I'm gonna show you right away. We can use this multi-add node and in relation with what we're going to do right here. So first thing that we want to do is we want to make sure that we're going to quantize our values. Now quantizing means in fact just having limited steps. It's like creating a smaller resolution. Well, perhaps it's a little bit more visible if I use a wave node over here. So we have this wave node, and let's make like this very long sine and have a little bit more amplitude, something like this. So we have like a lot of samples. I'm going to switch this off. If we create now a limit function, and we're going to quantize, and there are two things: you can quantize the index or the value. We're going to quantize the value, and if we round it, you see we're starting to get less resolution. So the higher we get this value, the more it's going to snap to a multitude of these values. So it's really useful to create like all kinds of discrete steps. Now in the same sense, we want to have these discrete steps right over here. We want to make sure that all of these sample points are fitting exactly on the spot where we want to have it. So right here we're going to do also a quantize, and since we have like a total number of 5 points, so this means like 1, 2, 3, so 1, 2, 3, 4 segments, it means that we can do a value of 1 divided by 4, and this is giving us exactly the right subdivision that we want to have. Now the same thing over here, which is in the math node. If we multiply it then by 4, we have everything sticking right on the exact positions where we want to have it. Okay, so what we're going to do for that, we're going to make it easy for us. We're going to copy over here the parameter, and in this limit I'm going to paste the relative reference. I just have to do it again. 1 minus this channel. So this is this giving us something? Copy parameter. This is the gain value. Let's see. Gain, yes. But it doesn't seem to be working properly. Oh no, it's not minus, of course, it's divide. I'm sorry guys. So now you saw it snapping together again. Right, so since we now have all these discrete values, and we just read it out over here, we have, it means that we have like already the proper information. So right now the only thing that we have to do is to put over here in the ornament selection our stamping function. So if we do a stamp of the object right here, stamp, and we're gonna have like the copy 1, comma, copy 1, comma 0. And then we should have normally seen our proper results, but we're not having, oh, it's because I have copy 1 over here. Voila. So this is what's happening right now. So we have our values being read out in a proper way. Now there's still something else that we want to do, and that's the following. Right now we have like this pattern, but it's like unequal. There's a beginning and a start, and it's not having like a perfect ending and perfect start of a pattern. So we're going to control this a little bit more, and for that we're going to go right in here, and what we need to do is we need to find a proper repetitive pattern. And for me, a proper repetitive pattern would be like a piece in between this one and this one, so we have like the same start and the same ending. Okay, so we're gonna do it the following. We add another node, which is going to be a clip. Is it clip? No, it's over here in timing. We can find it at trim. So trimming is like making it shorter. So I'm gonna take this part, or even this part, taking it a little bit closer and bringing this all back to one thing, like this. And if we do our limits, we do our math, everything is there. So right here with our output. Now the only problem is we're still not starting from a value of 0, and something we need because our nodes are going to start reading from that point on. So now at the back over here, again we're going to use a timing utility, which allows us to shift. This sucks. Well, switching over to mouse for now. This should help me out. So the start is going to move up a little bit, so we have like starting from the value of 1 and ending with the value of 12. Okay, so if we go up again and we go to our resample, we see we have like a little part and the rest is not being done. Well, that's quite logical, because if we go back into our node and we zoom out, we see we have just one thing and the rest is all the same value. So for that, as a last part, we're going to use a cycle system. And in the cycle, I don't have to mirror, but I can say I want to have like 10 cycles after and 10 cycles before. And perhaps I still have a little bit too much selected, so over here in the trimming, I'm gonna trim it just a little bit more, like this, so we have at the end exactly what we want. Is this exactly what we want? No, that doesn't seem to be okay. It's limiting, and this should be it. Yes, yes, shift cycle. Is a cycle not perfect? we don't have to blend mirror cycles. And this is quite strange. I don't know why exactly we're having this. Blend region is a region of 0. We don't want to blend. We don't want to mirror. Okay, now it seems to be better. The reason why it was a little bit distorted was because there was a blending value. So the bigger the blending is, the more one goes into another. So that was the reason why we were having a problem over here. But as you can see, we now have like a repetition of what we have. Now you could say that there in fact was no reason for me to do this trimming in the first place, because, well, I already had like this very long thing, and why just not use that one? And that's something I'm going to show you later, why exactly we do this. For now, let us just show this. So again, we have this repetition. We know, because we were counting this part, that it is from 0 to 11. So this means that our segments are 12 segments big in order to have like a complete thing. And so if we multiply it with other values such as 4 over here, we get like this nice repetitive pattern, which makes good sense over here. But now we don't know probably beforehand how big our pattern is going to be. Sometimes it may be very long or it may be very small, and it's not a value something that I want to each time end up adding manually over and over again. So we're gonna measure it together again with an expression. Again, you can find all those expressions on exactly the same spot, so that's something I'm not going to show you. Instead, I'm going to go right to here, and we're going to read out from this last value like this. This is going to give us the perfect measurement over here, and I call this one length. Length. Come on, length, like this. Alright, so here in the sample, the 12 we have over here, that's something I want to change by an expression right now. So that one is going to be the chop L, chop length. It's quite easy. Again, we're going into the ChopNet, and what it says over here is the string chop. It's not saying string channel, so this means you don't have to go as deep as in the previous one. So if you just go over here and we select the length node right here, that's deep enough. You don't have to select another channel. It's going to take the longest anyway. So now you see right automatically it's going to give us the number of 12, and we can multiply it with over here again with 3, something like that. Whatever you want to use. Okay, so this means we have quite a flexible system right now, because if I want to, let's say if we make something more complex like this, we add another wave system, and in this case I'm not going to use a sine, but I'm going to use a pulse. And let's see what this pulse is going to give us. What am I doing? I'm just adding over here a pulse. Let's see that we have like a proper pulse matching something we have already over here. It's better to use like full numbers. Is this going to give us a proper result? Is this going to give us a proper result? Perhaps something like this. Let's see. This results in, yeah, something nice. And let's use another one. Not this one, but say a number of 16. No, that does not give us a nice result. 18. Well, perhaps it's going up over here, big difference over here. Or what is it? Main if you use a sine. That's a little bit too wavy. Triangle, no. Ramp. Now I'm going to use a pulse. Well, a pulse something like this. So we have beginning, start, end of this part. Right. Let's go to the trimming operation of this. So this is not a port that I like to have. I'm going to take this part right here, just one less. Limit the function, so it's normalized, being added. And now over here we have the resampling, which is not enough detail. You see everything is being moved out, but there's no problem because we can add more detail right here with the add function. So do we use 7 or 8? 8 seems to be fine. Now the shift we still have to do again. So shifting that we start off from 0, and this gives us the proper length. Now we have the cycle, it gives us a proper cycle and output. So if you now go up and we see the copy node, well, immediately this is a little bit too crowded, so let's increase the size of the circle, or perhaps let's downscale our objects. It's just all the same. And as you can see, it's just creating like this nice patterns of shapes. Perhaps I'm going to use just 2 of those. So we have like small objects and then suddenly very large objects being used and so on. And they all have like their related patterns to each other. So you can use this, of course, with lots of interesting things, such as for temples or other complex buildings, or more controlled agreeable stuff. So basically what we did right now is, instead of just using random values, random parameters all over, this tool allows us to create like properly defined patterns, and just have to play along to have like different results. I'm going to show you another method which is a little bit more flexible and also can give you interesting results. And that's, instead of using like manually all these nodes, we're going to create a noise node. And if we have like this noise over here, we're gonna change it again so that we have like a size of 100, and we have our thing put up in frames. So if we make it bigger, oh, that's the seed. The period, we have to make it a little bit bigger, so we have like all kinds of results. So trimming just a single part of it, doesn't matter. We can limit it. So this is the whole normalization process, making sure it's using all kinds of nodes, putting it right on the spot. And now we still want to give it a little bit of feeling of structure, and that's something we don't have right now because it's just like a random value, but we can solve this quite easily by just adding another cycle node. So what we're going to do is, if we just mirror the pattern we have over here, then we have something which feels more like human made. So we're gonna make like one cycle after. I'm gonna mirror the cycle, and we're not going to blend, and the region we're going to set to 0. So right now you see we have like an interesting structure. Over here in the math, I'm going to put the samples down, let's say to a value of 7. So this gives us just enough for what we need, and I'm going also to trim a little bit more. Do some more trimming over here at the end, so making it a little bit shorter. Alright, so this is going to give us a little bit more relevant. So less samples over here. We can even turn it a little bit more down. Doesn't matter really. And then if you want, you can just start playing around with the seed, and the seed is going to give you all kinds of like interesting results. Now let's make it easy for us. Let's add immediately our time over here, so we can see directly all kinds of different results. Now the same thing as what we had before. Everything's put on the right spot. We have like proper length measuring and cycling of the whole thing. So right now, if we go to our copy node, we see we have like a proper selection of nodes, and we have all kinds of different and sometimes interesting patterns going on. Let's increase it again, the resampling. Let's set it to 4 in this case, and you might come up with quite some interesting structures. Now also a great advantage, making it a little bit more powerful than what you have with randomness, is something, well, I'm going to show that in the third part of the lecture.